Hopefully at this point you've tried the assignment that was following lesson 4. We're now moving to lesson 5. This will be new material. We'll be tested on this at the end of the unit, in addition to all the stuff that was on the mid-chapter assignment. Today we're going to be looking specifically at circles, properties of circles. Now there's a lot of words at the beginning of this. Read them over, think about them. The picture sort of tries to demonstrate all the different parts and pieces. Some of these words you know already: a radius, a diameter, but some new ones. We have an arc, which would be a curved exterior line of the circle or part of it, a chord, which is a line that travels through a circle but does not go through the center, and a tangent, which is a line on the exterior of the circle and makes just one point of contact with that circle. Okay. Pythagoras comes in handy in all kinds of places. We've been using it in cones and pyramids and prisms and two-dimensional shapes like triangles, but it also comes in handy when we're talking about circles. In particular, when we're talking about chords and diameters. So if we look at the first example here, I want to find the length of chord AB. Now looking at that, AB is this from A to B, the length of that has been broken in half by this vertical line, giving us 2 equal segments. If I can find the length of one of the segments, I can double it and I'll get the length of the other segment. Looking at that, it kind of reminds me of this right angle triangle that we have a Pythagoras idea here. In particular, we have a squared plus 3 squared makes 5 squared. And to solve that, I need numbers on one side and letters on the other, so I have to rearrange this. I get a squared is 5 squared minus 3 squared, or in other words, a squared is 16. And if I square root that, I get a is 4. And now that's not the length of AB, it's just the length of 1/2 of that. To find AB, we're going to double that, so 2 times 4, we end up with AB being 8 centimeters. Another use of Pythagoras. If we look at the second one, letter B, I'm sure you guys can figure out where this is going, but if I want to find the diameter AB, I can do that knowing 2 chords meeting at a right angle and using Pythagoras again. In this case, side C would be my hypotenuse, right, across the right angle. So 24 squared plus 7 squared equals C squared. If I put that in my calculator, I don't have to rearrange, it's already in the right spots. I get 625 for C squared. I square root that, and C would be 25 centimeters. And again, another use of Pythagoras. Okay, if I go to the application one, give it a try, read it over so you can draw the picture. It's probably the hard part of this one. And see what's going on here. So we have a log that's going to get cut. Okay, so if I have the log, and then I cut off a portion, let's call it like that, I'd be left with this cut, right, to the log. Okay, and they're telling us that the exposed surface has a length of 24 centimeters. I want to know the distance from the center, right there, to the cross section. Right, so I want to know what that is. Now, if we read the question initially, the first line of it tells us that the radius to the point on the outside would be 13 centimeters. Look at the diagram I just drew. I can recognize that as a right angle triangle where I need to know this value right here, letter A, and I can solve that using Pythagoras again. Okay, so I got a squared plus b squared. Now b, you gotta be a little careful here. B goes from here to there, which is half of that distance, right? It's 12 centimeters, so plus 12 squared equals 13 squared. To solve it, numbers on one side, letters on the other. So we'll rearrange 13 squared minus 12 squared. I put that in my calculator the way it looks. I get a squared is 25. When I square root that, I get a is 5 centimeters. Here's how we can use Pythagoras inside circles, dealing with chords and diameters and such.